Okay, hi guys. First of all, I would like to start with the wave nature and give the simple definition and equation for the wave motion. First of all, let's suppose uh, that you have a straight line that is say a coordinate plane that is y and x here, and suppose that the equation of my line here is 1/3 of x. So that's just a line here, and it's not moving. If I want to move it in a plus x direction, let's suppose that I have plus x direction. All I have to do, suppose that I want this line to move with the 6 meter per second speed in the right direction. So all I have to do that I have to replace the definition of x by the x minus 60. So you see here, if I plug it into this equation instead of x, the equation of my movement will be equal to y is equals 1/3 of x minus, and if I multiply it by 6, you see here that it will be minus 2t, because the 6 is simplified by 3 here, and it gets minus 2. So now that's the equation of my movement. If you see, after 1 second, it will be here, somewhere here. And if I want to guess these points here, that's intersection with the x point, so all I have to do is that to see that the y will be equal to 0. Let's suppose the y is 0 and t is equal to 1. I suppose that the 1 second is passed here. So since 0 is equal to 1/3 of x here, minus 2, so you see here that my x here will be equal to 0. So the point here will be equal to 6. On the other side here, of course, if I assume that my x here now is 0, so the y will be, I will plug it into this equation here. So y will be equal 1/3 of x and minus 2. So the intersection with this line here is minus 2. That's the movement of just a line here. What about the wave? So I'll come up to wave now. Okay, guys. So now I'll try to draw a line here. It's my wave here. And suppose that I have the equation for this wave. Suppose that is, let it be 3. Now let's continue. So suppose that my y is here 2 of sine of 3x. What does it mean here? It means that my amplitude here, maximum declination here is 2, and of course, by the way, symmetrical, it's here minus 2. And what about this 3 that's here given here? So this 3 means here that the sign, the meaning of sine is 0 here and here also. So I know that, of course, if the x will be equal pi over 3, if I multiply it by 3, you see here, if I multiply it by 3, it becomes, my equation here, becomes sine of 3 times pi over 3. So it will simplify it, I'll get sine of p here. So I go on, it becomes here sine of pi, and I know that sine of pi is equal to 0 because that's 180 degrees. So here I have to plug that this point here will be pi of 3. And of course, it's in symmetrical, it's twice greater than this one, it will be 2 pi over 3. And you see here, so the line here, starting from this point to here, is called as a lambda. And you know that as a lambda is called as wavelength. Wavelength. The wavelength, and this point here, that is in front of my sign here, that is called as, let me write it here, it's called as amplitude. So, but my line is not now moving, as in the previous logic here. All I have to do is just replace here the x. If I want to move it with the same velocity, suppose that the velocity is the same, 6 meters per second in the plus x direction. All I have to do is just rewrite the x here by x minus 16. And by the way, if I write it here instead of x here in this equation, my equation will now become as y is equal to 2 sine of 3x minus 18t. So if I just keep it in the brace here, it will be in the same way as sine 3x minus 16. By the way, of course, if I write the general expression here, I will rewrite the a by a here, this point here, amplitude. And by the way, this point, the number that's written here is denoted as k, and it's known as wave number. Wave number. And by the way, the thing here, the number that's in front of t gives me the velocity, of course, or the speed of motion. Speed of motion. So you see here, I will just try to rewrite the general expression for the wave. So you see here, that since I just replace the x by the x minus 6t, now it's moving, and you'll see after a certain time here, after 1 second, it will come up here. Finally, I will come up to the general expression that is y here equals a sine of kx here minus vt. So when you have this expression, you have all information about the wave. What I mean that the a gives you the amplitude, maximum declination, amplitude you have here. And if you know the k, you see that by the previous example that my k is equal to here 2 pi of lambda. And if you know the k, I mean you may get lambda, that is lambda 2 pi over k. So I mean the number that's written in front of k here, in front of x, sorry, gives me the k, that is wave number, and you'll use it in this expression that the lambda is equal to 2 pi over k. And by the way, if I open the brakes, the things will be a bit different. The a will be equal to sine of kx minus omega t. And you know that the omega, by the way, is the angular velocity. Angular velocity that is measured in radians per second. By the way, of course, what's the relation between v, velocity, k, wave number, and omega? You know that that is omega. You'd like this expression because all the young people like this expression. The omega is equal to vk. So that is resembles something, vk of contact. You see, that's omega equals v times k. So as I said before, everything is given here in this expression. So I hope that's clear. So in this expression here that I've denoted before, y equals a times sine of kx minus vt, or y is equal to sine of kx minus omega t, every information is given here. If you know the k, I denoted, you may find the lambda, I mean the wavelengths of the wave. And if you know the v and k, you may find the angular speed. And let's come up to the example. Let me show one example here. Let's suppose that my wave has got the expression. Let it be an example of, for example, here. Let me give it, if you wish, the number of 3 here, and the sine of, let it be k. That is, let it be 5x here, and minus, let it be. By the way, if I write here the plus, it means that the wave is moving not in positive direction, but in negative direction, in minus x direction. But nothing strange here, nothing is so nothing to scare here, but I'll write as plus here. So you have to understand that now my wave is moving in a minus x direction. So let it be, for example, 5x plus, let it be 2t. So what I have to do, first of all, I want to find the wavelength of this wave that's moving here. So now the number that I need is the number that's in front of x here. That's in my case, that is 5. So I have to divide pi k over 5, 2 pi, sorry, over 5. So I'll get here that is 0.4 multiplied by pi. If you wish, I can write it in terms of number here, 3.14, or let it be round as 3 here. So 0.4 times 3, that is 1.2 meters. So that will be my wavelength of my wave that's moving. And now what about the angular speed? I know that my speed here or velocity equals 2 meters per second, but in negative direction. So I can write here, if you wish, the minus sign. It moves in negative direction. So, but it's not so important here. So as I expressed before, if you know the v and k, you may find the angular speed. So my v here is equal to 2, and 2 multiplied by 5, I get 10 radians per second. So I write here indeed in Russian, so radians per second. That's the measure or unit for the angular speed here. By the way, the expression is valid for all of the waves here. I mean, that's also suitable for electromagnetic waves. So you know that electromagnetic waves. So before I come up to the electromagnetic waves, I want to clarify these things here that I see here, that I have the circle here, that wave nature. I have to express you the including electromagnetic waves, sound, say waves, amplitude, wavelength, frequency, and period. So if I know the angular speed here, angular speed, of course, you know that the angular speed is directly proportional to the frequency. That will be 2 pi f here, and you know the pi is 3.14, and you can find the frequency here, of course. And the frequency, by the way, is measured in hertz. It's denoted by Hz, hertz. Of course, it won't be so difficult to find out the frequency here if I divide the omega by 2 pi, omega over 2 pi. I'll have the frequency here, and in my case here, I mean in this example here, I have the omega as 10 radians per second, and it's divided by 2 times 3 here. And you see here that is 10 over 6, and that will be approximately 1.66, blah, blah, blah. I don't know exactly. So you can find it, or you may denote it as a rational number here. Usually it's denoted, if I simplify it, by 5 over 3 here, and that will be approximately 1.7 hertz here. What about the period? Of course, the period is inversely proportional to the frequency. That's one of the f here. So if I turn upside down the frequency, you know that I have here the frequency of 5 over 3. If I turn upside down here, that will be 0.6 seconds here. By the way, the period, since it's a measure of time, is measured in seconds here. And I hope that I gave the definition for the amplitude. By the way, amplitude is the maximum declination from the equilibrium point, and the wavelengths, of course, that's the length here that I've showed in the graph, and the frequency is the number of vibrations in 1 second or in a period of time. And what about the period? The period is the time needed for one complete revolution or one complete oscillation here. And that's all. I hope that the next time I'll come up to the electromagnetic wave, and if you have the questions related to the subject that I've explained it, please let me know and write here. I hope that will be useful for you. If you have certain problems, certain questions related to this subject, wave nature, amplitude, wavelength, frequency, period, and the motion of a wave, you may ask me anytime you wish. See you.